Question number 94 from June 2020. Consider the partial differential equation. So 2D equations are given, 1 and 2. So we have to find which of the following statements are true. 1, 2, 3 and 4. There's 4 options are given. Okay. So let's start with, so we have one equation, so partial differential equation, such that this A del 2u del x2 plus B del 2u del x del y plus C del 2u del y equal to 0. So for this partial differential equation, it will be parabolic if b square minus 4ac is equal to 0. It will be elliptic if b square minus 4ac less than 0. Point number 3, it will be hyperbolic if b square minus 4ac is greater than 0. Now we will check with our options, with our equations, partial differential equations. So we have a sine of y, that is the signum function, which states that, says suppose the sine of y, it means that mod y by y, so it equal to, so this value will be equal to 1 for y greater than 0, minus 1 for y less than 0, right? So now check with our differential equation. So we have del 2u del x2 plus 2 del 2u del x del y plus 1 minus the sine y function del 2u del y2 equal to 0. So what will be the b square minus 4ac? So b square minus 4ac will be b is 2 square minus 4 into 1 into 1 minus sine of y, which is nothing but this. If you do this, it will be 4 sine y, because this 4 and 4 will cancel out, right? So we know already from this, we already have this, so y equal to 0, so y less than 0, or we can say for y less than 0, this equation 1 will be elliptic, and for, so it is in the third and the fourth quadrant, and for y greater than 0, it will be hyperbolic. That is our first and second quadrant, right? Now check with the option, this second differential equation, partial differential equation. It is given that y of del 2u del x square plus x of del 2u del y square, right, equal to 0. Okay. b square minus 4ac will be simply minus 4 of xy equal to 0. So when xy greater than 0, it will be elliptic in our case, and when xy less than 0, it will be hyperbolic for this differential equation. So it will place in the hyperbolic in the first and the third quadrant, and it will be elliptic in the second and the fourth quadrant. Okay, so let us check with the options. So here it will be equation 1 will be hyperbolic for y greater than 0. So option 2 is the correct one, and elliptic for y less than 0. And equation 2 is hyperbolic in first and third quadrant and elliptic in the second and the fourth quadrant. So it is our correct option. Question number 98, we have to find the extremal of the function is of the form. We have to find the form of this function. So what is given that first of all, this j of y is given integral 0 to 1 e to the power x 1 plus y whole square dx, where y is in the C2 closed interval 0, 1. So Euler equation we have Euler Lagrange equation. This equation gives that del f minus del y minus of d dx of this del f del y dash is equal to 0. So when we do this, so you will find that d dx of del f del y prime is 0, and on integrating this term we will get, it is nothing but the del f del y prime equal to c1. So now del f del y prime is e to the power x 2y prime by 2 into 1 plus y prime square. This is equal to c1. So when on squaring both sides, so we will have this e2x 2y prime square equal to c1 square multiplied by this, it will be 4. Okay, so here it will just cancel it out, we can, so we just y prime square, right? It will be y prime square, and it is c1 square multiplied by y1 square. So this is that. Now if we do the further simplification, so c1 square plus c1 square y prime square, this is equal to this, we can write it in this form, that y prime, so taking in this side, so it is just let's write the full equation. So c1 square equal to c1 y square, y prime square will be there, so we can take y prime square common, e to the power 2x minus this c1 square, right? We can do this. So now simplify to this y prime square 2, so this is c1 square by e to the power 2x minus c1 square. or we can do this square root y equal to plus minus c1 by root over e to the power 2x minus c1 square. Okay, so if we took the c1, so plus minus 1 by, we can took this over here, that e to the power 2x by c1 square minus c1 square by c1 square, which will cancel out, so we just keep it as 1. Yes, and now we can, if we do the integration, so this is y prime. Okay, so this is y prime, first derivative. Okay, now we can do this y prime equal to plus minus 1 by e to the power x by c1 whole square minus 1. So integrating side, so if we do this integration on the both sides, so it will be y equal to plus minus 1 by root over e to the power x by c1, that's whole square, minus 1. Right, now if we do suppose if we take this y equal to sec inverse x by c1 plus c2. Okay, so where the c1 mod of c1 is less than 1 and c2 is arbitrary, right? So we can do this ddx of sec inverse x, it will be 1 by x multiplied by x square minus 1, or we can write that sec of sec inverse x is integration 1 by x into multiplied by square root of x square minus 1. So sec inverse x by, so if we do this sec inverse x by c1, if we do this, right, so it will look like, so 1 by x by c1 root over x by c1 whole square minus 1, right? So this is the option, that is equation that is matching with our extremal functional. So our correct answer will be option 2. Okay, so this is our correct option, this is option 2.